All right, here is the beginning of the Math 8 Semester 1 review. The directions say, place the numbers into the appropriate circle. I think yours printed better than mine did. So if you look at mine, here are all of our numbers. Let's make a quick fix. This one should have the line on top of it, not below. Okay, remember, numbers are rational if they can be written as a fraction. So right off the bat, I have two numbers that I would like to write in the rational circle. 12 over 3 and negative 1/2. Those are clearly both fractions, so we'll put them in the rational circle. I would also go back and not forget that that number is there. That is 9. 9 can be written as a fraction. It can be written as 9 over 1. The square root of 36 is 6. It can be written as 6 over 1. So the square root of 36 is also rational. We come to this decimal here, which looks like it goes on forever, and it does not repeat. So it is irrational. What we have next is the decimal. That is 42 and 37 hundredths. I could write that as 42 and 37 hundredths. So absolutely, it hangs out in the rational category. And finally, let's not forget we have this little guy left. Square root of 8. There is no number, whole number specifically, times itself. That is 8. So square root of 8 is irrational. Then you are asked to plot the numbers on the number line. This is a lot easier when you have your calculator to use. Square root of 81, what times itself is 81? Well, it is 9. So your A goes right. Well, we could do that a little bit better, but your A is supposed to go right on top of 9. But then you have the next one, B, the square root of 65. Remember the way that we do that? Second, x squared, put the number in, and then hit your conversion button. When you do that, take a moment. Second square root 65. You get something like 8.06. So it is not exactly on 8, but I can put it right next to it. Then we get to 10 and 1/3. How do we change a fraction into a decimal? Well, you divide. So you get 10.3 repeating. So that's going to end up being around here. Let me backtrack for a second with this particular number line. Let's look at 9 and 10. It is broken up into 1, 2, 3, 4 parts. So it is broken up into quarters, like a dollar would be broken up into quarters. So this line right here would represent 10.25. Well, our number 10 and 1/3, 3 repeats. 3 is more than 2. That's why it's going to go over here on the number line. Okay, trucking right along. Complete each statement with equal to or approximately equal to. If in your calculator you would put the square root of 53, it does not exactly equal 7. It is approximately. And then B, 1.6, 1 3/5. The way that you change a fraction into a decimal is you divide. So you get 1.6. Those equal each other. Number 4. You have this number is a blank number because, well, it is an irrational number because it does not repeat and it does not terminate. By terminate, I mean stop. That sucker is going to go on forever. Number 5. Here are your numbers. Graph the following fractions and list in order from least to greatest. So here is your number line that you're going to do this on. We can start by just comparing two numbers. Numbers over here to the left are going to end up being negative numbers. So we're going to take a quick look at these two negative numbers. But at this moment, it is hard to compare them because one is a decimal and one is a fraction. I said, whoa! Turns out, let's change this into a fraction. You use your division, 3 divided by 8. So negative 0.375. Okay. Numbers to the left of the 0 on the number line go a little bit differently than our positive numbers do. For instance, this would be -1, -2, -3, and so on. Okay, so we have the general idea of where the numbers are placed on the number line, but what I want to do is I want to compare then this number and this number right here. On our number line, 2 is right here and 3 is over here. So this number is going to go further to the left on the number line. So I will put, they need to go over here though, because obviously those are decimals, but I was just trying to show you about where 2 and 3 are on the number line. So we'll put the -3/8 right about here and -0.2, really sloppily written, right over there. Okay. So those two are taken care of. We've written those. But now we need to compare 2/5 and 10/100. 2/5, we also need to write it as a decimal. So let's grab our calculator, take 2 divided by 5, and that is 4/10. Please compare the decimals as they are written. 4 is greater than 1. So when we place it on the number line, it would go 0 and 10/100 first, and then 2/5. Hopefully I didn't confuse you on this matter. Next question. What is the area of a square? And I think your keyword here that you need to recognize is square with a side length of 9 units. Essentially, it is asking you to take 9 and square it. That is 81 units. Moving on to number 7. Number 7 is one of my favorite questions. We've been doing it a lot in class. The square root of 10 is between the whole numbers blank and blank. Well, before we get there, let's think about the square root of 10 and what perfect squares, not whole numbers, perfect squares it is between. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So those are the two perfect squares that 10 is between. Square root of 9 is 3, and square root of 16 is 4. So the square root of 10 is somewhere between 3 and 4. Well, what would it be closest to? If you have these written here, it's easy to see. 10 is only 1 away from 9, which means it would be closest to the square root of 9, which is 3. If you don't believe me, there is a way that you can check yourself. In your calculator, hit second, x squared, 10, and then hit your conversion button. When you do that, you get 3.162 ... Well, 3.1 is closer to 3. You would round it down than it is to 4, if you wanted to double check yourself. Represent the following rational numbers as decimals. Do not round. This is a piece of cake with your calculator, because with your calculator, you are going to divide. On the first one, recognize 3 is your whole number, so put 3 into the left of the decimal, because that would tell you that it's the whole number. You do not have to put that in your calculator. But in your calculator, you should take 5 divided by 7. And you get this yucky looking yuck. Recognize that it asks you not to round, so get all of those numbers down. Next question. 3 divided by 11. If you put that in your calculator, you'll notice that it repeats. Put a line over it, and yes, in your calculator, eventually that 2 gets rounded up to a 3. Do you remember why? It is because your calculator ends up rounding it. Next, -6 can be written as a decimal by putting a decimal. You can't just write a decimal without having a 0 behind it. That's a lovely looking 0 at that. Finally, 2 divided by 15. In your calculator, you do get a 1, but it's the 3's that are the only thing that are repeating. If it is the 3's that are the only thing that are repeating, you need to put a bar over the 3. Okay, I am looking at number 9 and number 10 together. Number 9, I'm going to hit second. Number 10 is way more important. You will see something like number 10 on your final. X cubed equals 125 over 343. Okay. Remember, the whole goal of algebra is to get the variable by itself. It is being cubed, so you need to do the opposite. Take the cube root. What I do to one side, I have to do to the other. So if you take the cube root on the left, all that is left is the x. And with your calculator, people are getting confused. I don't want you to think that you just merely divide on your right. That is not correct. Like I said, you're doing the opposite, taking the cube root. It means what number times itself, that's why I'm using a question mark, because we don't know, but it's the same number every single time that would get us the 125 or the 343. We have done 125 enough to know that it is 5 times 5 times 5. So the cube root of 125 is 5. Now, that means that it's 343 is going to have to be more than 5. If in your calculator you take 6 times 6 times 6, you get 216. Still not enough. So let's try 7 times 7 times 7. 343. 7 times 7 times 7 equals 343, which means this cube root of 343 is 7. And before I forget, going back to number 9, it's essentially saying what number is 8 going to be the cube root of? So these two questions are the reverse of one another. Number 9 is asking you, if I take 8 times 8 times 8, what do I get? Well, 512. So it's saying the cube root, if I rewrote this, 8 equals the cube root of 512. That is why those two questions are the reverse of each other. Number 11 is going to be simple because you have a calculator. Again, in your calculator, hit second, x squared, 38, and then the conversion button. You should get 6.164, blah, blah, blah. These two number lines are a little bit different. The first number line is simply cut in half, so that would be 6.5. The second number line is cut into 10 spaces. So this is 6.1, 6.2, and 6.3. If our number is 6.164, for the top number line, obviously that's not half. It's closer to right in here. But our second number line is a little bit more spread out because you chopped it into 10. It is 6.164. 6.164 is more than 6.1, but less than 6.2. In fact, it's going to be about right there. It's a little bit more than halfway to 6.2. Use your calculator. It'll help you. Promise. Okay, number 12. This is where we will stop because you have your other video for number 13. John entered the following expressions into his calculator and got 2 different answers. Show the work that explains why the 2 expressions have different solutions. You cannot merely say, I put it in my calculator and that's why it worked. That doesn't work that way. With the one on the left, here is the big difference. There are no parentheses. So if there are no parentheses, the negative sign is just written. The only thing that is repeating is that 2. So if the only thing that's repeating is that 2, that's why your answer still has a negative. But on the next question, there is a parentheses. So everything inside of that parentheses is getting multiplied over and over again. If you plop that into your calculator, appropriately, you will end up seeing that the negatives, those two negative times a negative is a positive. Negative times a negative is a positive. They cancel out. That's why you get 16. Okay, I rushed through this. I apologize. But I figured this was a nice way to review questions 1 through 12. Good luck.